I'm going to be doing problem 45 from chapter 4. So we have Manny Ramirez, who hits a home run so that the baseball just clears the top of the bleachers, which are 21 meters high, and it's located 130 meters away from the home plate. The ball is hit at an angle of 35 degrees to the horizontal, and air resistance is negligible. So first we're going to try to find the initial speed of the ball. So to do that, we're going to use a kinematic equation, and we're going to use y initial, or y final, equals y initial plus velocity initial time plus 1/2 gt squared. So we can plug in that we know that the final, since the baseball just clears the top of the bleachers, it'll be at, we can just assume it's 21 meters there, so 21 meters. It starts at 1 meter high, so 1 meter plus the initial velocity. And since we're doing this in the y direction, we want to split up this initial velocity into its x and y components. So do that up here. This is velocity initial. And to split it up into components, this is 35 degrees. We will do velocity initial cosine 35 degrees and velocity initial sine 35 degrees for its x and y components. Okay, so since we're doing this in the y direction, we will have v initial sine 35 degrees times time plus 1/2 g time squared. Okay, so if you simplify this just a little bit, 20 meters equals velocity initial sine 35 degrees plus 1/2 gt squared. I forgot the time. Oops, there it is. Okay, so we have two variables here. We're trying to find the velocity initial, but we also have time as a variable. So to eliminate time, since we know that there is no air resistance, the x velocity stays the same. There's no acceleration in the x direction. So since that is constant, we can find the time by doing x equals velocity initial times time. So the ball traveled 130 meters in the x direction, so 130 meters equals velocity initial, and this is the x direction, so cosine 35 degrees, cosine 35 degrees times time. And then time is equal to 130 meters of velocity initial cosine 35 degrees. So we take this and shove it in over here. So we have 20 meters equals velocity initial sine 35 degrees times 130 meters over velocity initial cosine 35 degrees plus 1/2 gravity 130 meters over velocity initial cosine 35 degrees squared. To simplify this, these velocities will cancel out. 20 meters equals sine over cosine tangent 35 degrees times 130 meters plus 1/2 g, and then this will be 130 meters squared, and then 1 over velocity initial cosine 35 squared. Just keep this looking like that. Then, to simplify these numbers, I just calculated them out. This came out to 91 plus 123,410. I did the cosine 35, took that out, and then this is just 1 over velocity initial squared. So that's with everything calculated out. Also, I just remembered I made this mistake when I was doing it earlier. Gravity is negative, so this is negative. You have to remember that. Very important, otherwise this will not work. I made that mistake. this will become negative 71 meters equals negative 123,410 velocity initial squared. Okay, to move this over, velocity initial would be the square root of 123,410 over 71 meters. Put that into a calculator. Velocity initial is approximately 41.7 meters per second. Alright, part B is the time interval required for the ball to reach the bleachers. So, the time for the ball to get to the bleachers. Alright, so we will use another kinematic equation. X equals velocity initial times time. Trying to find the time, so time is equal to x over velocity initial. The distance is 130 meters. So 130 meters over, and we just found the initial velocity, which is 41.7 meters per second. But remember, this is the x direction, so remember to break it up into its x component, and to do that, just multiply it by cosine 35 degrees. Shove that into a calculator. 3.81 seconds is your answer. So this whole the whole time it travels is 3.81 seconds for the entire time. Alright, so part C is the velocity components and the speed of the ball when it passes over the top row. Okay, so to find the speed of the ball when it passes over the top row, right here, we first want to figure out how long it takes for the ball to reach the top of its parabola here, where the velocity will be 0 meters per second in the y direction. So y, hold on, can't see that. Velocity y. Okay, so we will use another kinematic equation. Velocity final is equal to velocity initial plus acceleration times time. Now, the velocity final at the top of this parabola will be 0 meters per second. It's equal to the initial velocity here in the y direction, which is 41.7 meters per second times sine 35 degrees, plus the acceleration here is gravity, so negative 9.8 meters per second squared times time. Time comes out to be 2.44 seconds. So it takes the ball 2.44 seconds to travel from here to here. So this is 2.44 seconds. That means that this part over here is just 3.81 seconds minus 2.44 seconds. And that is 1.37 seconds. So to find the velocity of the ball right here, we will use the same kinematic equation. Velocity final is equal to velocity initial acceleration times time. Velocity final is equal to 0 meters per second. The ball is 0 meters per second here at the top of its arc. And this is all in the y direction, by the way, so this is for the y direction. 0 meters per second plus 1.37 seconds times negative 9.8 meters per second squared. That comes out to be 13.43 meters per second. So the ball is 13.43 meters per second right here. Alright, so the very last part of this is to find the velocity components. So find the velocity components. Just write it like this. Velocity is equal to 34.1 I hat minus 13.4 j hat. And we got this by just multiplying out 41.7 meters per second times cosine 35 degrees. That's the velocity in the x direction, and this is the velocity in the y direction. So that's the components. And then to find the speed, the resultant speed right here, where the ball, right when it passes at the top of the bleachers, we can just take the magnitude of this vector. The speed will be the square root of 34.1 meters per second squared plus negative 13.4 meters per second squared. Calculate that. Put that into a calculator, and you will get 36.7 meters per second.